Fourth period class, I'm going to finish graphing this rational function that we began during class today. As you can see, I have done the long division, and right when I finished, we subtracted and we got minus 14x, and this is actually my remainder. So we have a slant asymptote here of y equals 3x. Now, the next thing I'd like to know is if my function crosses the slant asymptote. So in order to figure that out, I am going to set my function equal to my slant asymptote. And I'm going to do that right over here. Let's see, I like to work with the version that is not factored for this purpose. So I would have 3x to the third power plus 5x squared minus 2x all over x squared plus 4. That would equal 3x. Again, my function set equal to my slant asymptote. Now I'm going to multiply both sides of my equation by x squared plus 4. And I will get 3x to the third plus 5x squared minus 2x equals 3x to the third plus 12 plus 12x. Now, I'm going to subtract 3x squared from both sides, and that's nice because that goes away. Unfortunately, my x squared factor does not cancel, so I'm going to have to set the x squared term, I'm going to have to set this equal to 0 and solve. So that's 5x squared minus 14x equals 0. This does factor, so I can factor out an x. That's 5x minus 14 equals 0. So I'm going to cross the slant asymptote at x equals 0 and x equals 14 fifths, which is almost 3, not quite 3. So I'm going to cross the slant asymptote at 0, and then the y coordinate is going to be what I get when I plug in 0 for x, 0, 0. And I'm also going to cross it at 14 fifths, comma, and I have to multiply by 3. Let's see, that is 3 times 14, 42 over 5. So we have slant asymptote, I have 2 places it crosses, and now I'm going to make this all a little bit smaller so I can have things fit on the same page. Okay, so now let's go back up to the top. All right, so far I know there's a slant asymptote. It is at y equals 3x. Maybe I'll highlight that. That might be nice. And I know that it crosses at 0, 0, and 14 fifths, 42 fifths. Now, to move forward, I need to know some more things. There is no vertical asymptote because my denominator is never equal to 0. I do have some zeros. That's going to be where my numerator is 0. My zeros are going to be at 0, -2, and 1/3. And what else do I need to know? I think that is about it, but I'm sure I will realize if I'm missing something once I start putting this stuff on to a graph. So I'm going to highlight the pieces that are going to be valuable to us. The zeros I'm going to want to know. I'm going to want to know that there are no vertical asymptotes. I want to know that there is a slant asymptote. So I'm going to graph this. I'll draw myself a grid. And then I will start putting the things I know on the grid. So for example, I first need to start graphing y equals 3x. So the slope of my slant asymptote is 3, and the y-intercept is 0. So my y-intercept is 0, my slope is 3. And then I'm going to draw a dotted line to represent my slant asymptote. Like so. Now, the next thing I'm going to do is I'm going to plot my zeros. I have a 0 at 0. I have a 0 at -2. And I have a 0 at 1/3. Well, that one's going to be tough to draw. Right there. And I know I'm going to cross the x-axis at 14/5, or not the x-axis, the slant asymptote, at 14/5, 42/5. So 14/5 is almost, what is that? Almost 3. It's going to be right about there. Okay, and maybe I'll make those different colors so I know really well where my graph is going. I got one here, I got one here, I got one here, I got one here. Okay, now, how does this look? Is there anything else to draw? No, no vertical asymptotes. So I do know that my graph is going to approach this slant asymptote, but at this point I'm not positive how this looks. I do know that I'm going to connect these points between 0 and 1/3, and I'm going to connect this guy. I know for certain that my graph is going to connect those 2 points. Now, the question is, does it bounce here and go back up through, or does it go underneath? The only way to tell is to check a value between 0 and 1/3. I could pick 0 and 1, or I could pick 1/6 and just see, is it positive or negative? If it's negative, it's going to dip down under the x-axis. If it's positive, it's going to bounce back up. So if I look at my function here and I put 1/6 in for x, I would have a positive number, I would have another positive number. 1/6 is going to give me a positive number for my third, and then I'm going to have a positive number again. I am surprised. I am really surprised. So let's see. Did I get my 0 right? Yep, it's 1/3. 1/6 is between 0 and 1/3. If I plug 1/6 in, oh, I'm sorry. Here's the problem. This should be a negative. So I will get a negative value overall. So it will dip down underneath and it will come up here. The question is, will it bounce? It won't, but I can check at -1. What would my function be? Well, at -1, let's see, my x would be negative, x plus 2 would be positive, 3x minus 1 would be negative, I believe, yep, and then x squared plus 4 would be positive. So my whole function's positive. It's going to come up through here, it's going to go back down here, and it's going to then approach my asymptote. Over here, does it cross? I don't know. Does it bounce back or does it fully cross? Let's check. If I put a value in like 4, what do I get out for my function? Well, here I am sitting without my calculator, just like you guys. Let's see, if I put in 4, I'd have 4 times 4 plus 2 is 6, plus times 4 times 3 is 12 minus 1, that's 11, over 16 plus 4, 20. Okay, let's see, that's 24 times 11, 24, okay, so I would have 264 over 20. Oh, I really want my calculator. You know what? It's time to get my calculator. Time to pull out the big guns. Let's see. Calculator, calculator, where are you? Here we go. So 264 over 20 is what I would get if I plug in 4 for x. Now this is taking me a little while. Okay, let's see. I'm going to move this guy over. Maybe not that far. So let's just make sure I did that right. 4 times 6 times 11 divided by 20. That's 13.2. I still think I did it right, but it is 13.2. So let's see. So on my graph, I'm going to have x at 4, f of x, 13.2. The question is that above my slant asymptote or below? And the way to know is to check what the value is of my slant asymptote at x equals 4. At x equals 4, the value of y on my slant asymptote is 12. So this function is going to go straight through this asymptote, and it's going to start to follow it. Isn't that fun? Interesting looking function. I'm going to draw this again. I kind of don't like that this looks, you want to make sure it stays a function. Nothing is vertical on it. There we go. Really fun. Okay, so that's it. That's how to graph a rational function when you have a slant asymptote. See you tomorrow.